The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@yvcc.edu and I will respond as soon as I can. Today, eventually, we will be covering section 8.5, which has to do with absolute value equations. But first, we have lots of questions that came in from section 8.4. I have an assignment for you all, and that is some of the people asked the same question, but it may be the same numbers, it may be different numbers. So if I do a problem that like I've already done that one, can you please let me know? Just so we can save time. All right, so can everybody see the WebAssign page now?
Yes.
Yep.
Thank you. All right, it says solve the compound inequality, write the solution set, if one exists, in interval notation, and then graph it. So we have x is less than or equal to -4, or x is greater than 3. All right. Now we'll go to the board here. First of all, what does the word or mean that we're going to do? Okay, it means we're going to find the union. So we're going to take all of the first one along with all of the second one. Let's take a look at the graph of x less than or equal to -4. So let's see here, we've got -4. And if x is less than or equal to -4, we would have a bracket facing to the left with an arrow going to the left. So there's the graph of x less than or equal to -4. Any questions about that? All right. We've got x greater than 3, which looks like that, parentheses at 3 with the arrow going to the right. Now, or union means we take all of both of them. So if we were to graph the union, we would have this piece along with that piece. So the graph is going to have a bracket at -4 with an arrow going to the left, parentheses at +3 with an arrow going to the right. And then let's see, it says write it in interval notation and then graph it. So there's the graph. Interval notation would look like this. From -infinity up to and including -4 in union with not including 3 up to +infinity. So here is interval notation. Here is the graph. Any questions on that before we go on to another example? Okay, let's see, we're going to go on now to number 17. Let me get that up here and then we'll take a look at it. Okay, so 17 says find the solution set of the compound inequality. We have -7x less than -8x and 2x greater than x. Okay, so we're to find the solution set, and they don't say this, but it looks to me like they want us to graph it and put the answer in interval notation as well. So we'll do both of those things. All right, what does and mean? If or is union, what does and mean?
Intersection.
Right, where they overlap, what they have in common. All right, it's best to solve for x on the left. It makes it easiest to interpret these things. So the first inequality, I'm going to add 8x to both sides of the inequality, which gives me x less than 0. Okay. The second inequality, I'm going to subtract x from both sides, and that gets me x greater than 0. Okay. So again, what does and mean? It means intersection. So this is what I'm going to deal with, the stuff below the line there. Well, x less than 0 would look like this. You'd have parentheses, or I don't know, a parenthesi, whatever half of a set of parentheses is, with an arrow going to the left. So we're not including 0, we're including everything below 0. And then x greater than 0, we'd have a half set of parentheses at 0, arrow going to the right. Now, intersection. Well, this graph starts below 0. This graph starts above 0. So is there anything that overlaps? No.
Only 0,
No,
right?
0 isn't
So there's no,
included in either one.
well, I was going to say, so there's no solution?
Yeah, it's 0, right, okay. So this is below 0, this is above 0. 0 isn't on either graph. They don't overlap, nothing in common. So no solution, null set. All right with that?
Yep.
That takes us to number 21. Okay. And here we go. All righty. Solve the compound inequality and write the solution set in interval notation. So here they don't want a graph, they just want interval notation. So we've got -2 less than or equal to 4 minus 3x over 4 less than or equal to 2. Okay. So let's clear the fraction on the inside, in the middle there. So I'm going to multiply each piece by 4. So this times 4, this times 4, and that times 4. So on the far left end, I get -8. I did not multiply or divide by a negative number, so I will not change the direction of the inequality symbols. The 4 up here and the 4 down there reduce out, so I get 4 minus 3x in the middle. Less than or equal to 2 times 4 is 8. All right, so we've cleared the fraction. Again, I need to get x in the middle. So the next thing I'm going to do is subtract 4 from all 3 pieces. So I get -12 less than or equal to -3x less than or equal to 4. Yeah. Come on now. All right. What do I need to do now?
Divide it all by 3, -3.
There you go. And dividing by -3, we get 4. We change the direction of the inequality sign. We change the direction of the inequality sign. And over here we get what? -4/3. But now I've got this thing going from largest to smallest, and I need it to be from smallest to largest. So I'm just going to flip the whole thing around. So that's basically the same thing. We talked about that yesterday. Okay. Now, to write that in interval notation, it's going to include -4/3 because of the equal to, and it's going to include 4 because of the equal to. So brackets, -4/3, comma 4 inside. Questions on that? All right, we're going to go on and we're going to look at 22A. Let's see here. Okay. It says, solve the inequality in part A, then use your work from part A to determine the solution set for the compound inequality in part B. No new work is necessary. And again, the student got part B right, so we'll just look at what's going on with part A. It says x plus 2 less than or equal to 11, or x minus 2 greater than or equal to 3. And it looks like we're supposed to graph it and write it in interval notation. So let's take a look at that. Or union, we want all of the first one along with all of the second one. So to solve the first one, I'm going to subtract 2 from both sides, x less than or equal to 9. To solve the second one, I'm going to add 2 to both sides, x greater than or equal to 5, and we're talking or union. So x less than or equal to 9 would be a bracket at 9 with an arrow going to the left. Okay? X greater than or equal to 5 would be a bracket at 5 and an arrow going to the right. Now, if it was asking for the intersection, it would just be everything between 5 and 9. But it says or union. So it wants all of that along with all of that. Well, if you put them together, you've got everything. So our graph is basically going to be a solid line over the top of the graph, and interval notation, negative infinity to positive infinity. Okay. Any questions about that? Okay, we're going to go to some other problems here now. Give me just a minute to get those up. Let's see. And this is again at 8.4. Starting with number 5. Okay. Now, as I mentioned, if I do one that has the same numbers, please stop me. I don't want to take the time to do the same problem twice because there were a lot of questions this morning. Solve the compound inequality, write the solution set in interval notation. Now, I'm not sure the student asked for this one, but they got it correct. So maybe they just got lucky. I don't know, but we'll take a look at it. So we've got, let's see, which one is this? This is number 5. It says 4x plus 2 less than 3x minus 3 and x over 4 plus 7 less than or equal to 5. It looks like we're supposed to get the interval notation and then also graph it. Okay. So, and intersection. I'm going to solve the first inequality by subtracting 3x from both sides. X plus 2 less than negative 3. Subtract 2 from both sides. X less than negative 5. On the right side, I'm going to solve the x on the left. I'm going to subtract 7 from both sides. X over 4 less than or equal to negative 2. Then I'll multiply both sides by 4. X less than or equal to negative 8. So basically what I'm dealing with is that. X is less than negative 5 and x is less than negative 8. Okay? All right. So I think I'm going to copy that on the next page just to make sure I've got plenty of room. X is less than negative 5 and x is less than or equal to negative 8. All right. If x is less than negative 5, the graph of that, we would have parentheses, an arrow going to the left. So everything below negative 5. If x is less than or equal to negative 8, negative 8, we'd have a bracket at negative 8 and arrow going to the left. Now, and means intersection. Where do they intersect? Well, the first one is everything below -5. The second one is -8 and below. So they intersect up to and including -8. So our graph would look like this. So it's basically just like the bottom graph. And interval notation would be -infinity up to and including -8. Questions on that one? Okay. Going on. We'll take a look at number 6. And let's see here. Find the solution set of the compound inequality. We have 3/2 x plus 1/5. Oh, excuse me. Come on. Please work. Finally. Lesson 4 and 3x plus 3 greater than 15. Find the solution set of the compound inequality. So here we just want to get the compound inequality. Okay. And let's see. Let's go back and take a look at the page here. We're dealing with and, so that's an intersection. The first inequality, the LCD is 10, so I'm going to multiply both sides by 10. So 10 times 3/2 x plus 10 times 1/5 less than 4 times 10. 10 over 2 is 5, so 15x plus 10 over 5 is 2 is less than 40. So 15x plus 2 less than 40. I'm going to subtract 2 from both sides. 15x less than 38. Divide by 15x is less than, let's see. I don't think 38/15 reduces, so we'll just leave that. We could write it as a mixed number, but we'll leave that. Then the second one, subtract 3. 3x greater than 12. Divide by 3. X greater than 4. And this is an and situation. So again, I'm going to recopy that on the next page. X less than 38/15 and x greater than 4. Okay, so 38/15 as a mixed number would be 3 8/15. No, 2 8/15. Excuse me. 1, 2, 3, 4. 1, 2, 3, 4. So 2 8/15 would be, we'll say approximately, somewhere around there. Okay, so that's going to be 38/15. So I'm going to have parentheses and an arrow going to the left. X greater than 4 would be parentheses, arrow going to the right. But they want the intersection. Is there any intersection? Is there anything in common?
No.
No. So no solution. All right. Let's see here. And let's go on here. And here. Solve the compound inequality. Write the solution set if one exists in interval notation, and then graph it. Again, I'm not sure why this student asked for all these questions, because they've got all the right answers. So I don't know what's going on there, but maybe they got them through luck or something. I don't know. Anyway, solve the compound inequality. So we've got, let's see, this is number 12. and -4 times the quantity x plus 7 greater than or equal to 4, or 2x plus 5 less than 11. Okay. So solving the first inequality, we're going to get -4x minus 28 greater than or equal to 4. I'm going to add 28 to both sides. -4x greater than or equal to 32. Divide both sides by -4, so I turn the inequality symbol around. X less than or equal to -8. Okay. The right side inequality, subtract 5, and we get 2x less than 6. Divide by 2x less than 3, and it said or, so we want the union. So x less than or equal to -8 is going to look like that, everything below and including -8. X less than 3, wait a second, is that right? X less than 3, yeah, that's going to be here. So the top one is everything -8 and below. The bottom one is everything below 3. So what would the union be? Basically, it would be just like the bottom one, wouldn't it? Because it'd be everything below 3, which would include everything below and including -8. So that graph that I've circled would be the correct graph. And interval notation would be -infinity up to, but not including 3. Okay. Number 15. Solve the compound inequality, write the solution set in interval notation. 0 less than x, or 3x minus 5 greater than 4x minus 9. And so we'll take a look at that. All right, the first one is already solved. It says 0 is less than x, but I'm going to write it with x on the left. So if I just flip that thing around, if 0 is less than x, x is greater than 0, right? I didn't change the direction of the sign. I just took the whole thing and changed its viewpoint. This one up here, I'm going to subtract 4x from both sides. -x minus 5 greater than -9. Add 5 to both sides. -x greater than -4. Divide by -1x. Change the direction of the sign. So I've got x greater than 0 or x less than 4. Okay. Now I'm going to recopy those. X greater than 0 or x less than 4. So if x is greater than 0, it would look like that, parenthesis at 0, arrow going to the right. X less than 4, it would look like this, parentheses at 4, arrow going to the left. But or means union. Well, if you take all of it, you've got the entire set of real numbers. So it'd be a solid line and -infinity to +infinity. Okay. Let's see here. Number 19. Solve the compound inequality and write the solution set in interval notation. 2x plus 5 greater than or equal to 13. and -3 times the quantity x plus 3 greater than or equal to -21. I don't think I'm going to get through everybody's questions this morning. So if I don't get through yours, I'll try and contact you and see if you can come during the office hour, but we'll see. I mean, a lot of these are the same questions that other people ask. They may just have different numbers, but anyway. Okay. So solving the first inequality, I'm going to subtract 5 from both sides. 2x greater than or equal to 8. Divide by 2x greater than or equal to 4. And distributing the -3, -3x minus 9 greater than or equal to -21. Add 9 to both sides. -3x greater than or equal to -12? Is that right? Divide both sides by -3x is less than or equal to 4. So I've got x is greater than or equal to 4 and x is less than or equal to 4. This is kind of a strange one. This is just sort of an oddball one, because if we graph that, we get 4 and greater. If we graph this, we get 4 and smaller, but it's intersection. So the only point that is included is 4. All right. So what's that going to look like? Well, this is kind of weird, but this is how you'd write it in interval notation. And that's how you'd graph it. So you've got the interval from 4 to 4, including 4. I know that just seems really inefficient, but that's how it's done. Okay, let's see here. 21. How are we doing for time? Okay. All right, this one looks really familiar. Didn't we do one like that already?
Yes.
I thought so. Okay, okay. So let's see here. All right. Let's see, we need to go to 4770. Are you looking at WebAssign right now?
No, it's your PowerPoint.
Okay, good, good. Wanted to make sure. Wanted to make sure. Oh, okay. Okay. 8.4. Number 15. Okay. How about this one? Did we do one like this? I don't think so. We have maybe similar, but not exactly. Okay.
Yeah, we did that one.
We did this one?
Yeah.
Okay,
one like
all right.
that.
How about that one?
Yeah, didn't we do 22?
I know we did 22, but was it the same numbers?
I don't remember.
No, it wasn't.
You know what? I'm looking at the time. I'm going to bail on this because I need to get the new lesson. A couple of people didn't get all their questions answered. I will be tracking you down later on to see if you're still having issues after we've done ones that were similar to that. Okay. My apologies, but there's not enough time to do everybody's questions. And so I will get to you later. All right. So having said all of that, let's take a look at this next section. Okay. Which is section 8.5, the 8.5, excuse me, 8.5. It has to do with solving absolute value equations. Okay, now in the textbook, it actually covers absolute value equations and absolute value inequalities, but we're only going to be dealing with the absolute value equations. Okay, so here we go. Now, let's review what absolute value means. The absolute value of 6 is 6. The absolute value of -6 is 6. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of -2 is 2. The absolute value of 0.7 is, whoops, 0.7. Absolute value is a distance. It's the distance from that number on the number line to 0. But distance isn't measured in negative units. So if we're talking how far it is from 6 to 0, it's 6 units. So the absolute value of 6 is 6. But if we're talking about how far it is from -6 to 0, it's also 6 units. So the absolute value of -6 is also 6. The only time an absolute value is not positive is the absolute value of 0. How far is it from right here to right here? 0 units. Okay? Now, let's see here. Let's say I had an equation that said the absolute value of x equals +7. All right. How far is it from 7 to 0 on the number line?
7 units.
Good. How far is it from -7 to 0 on the number line?
Same.
Right. So for this equation, x could equal 7 or x could equal -7. If we put 7 in here, the absolute value of 7 is 7. If we put -7 in here, the absolute value of -7 is 7. So there's those two values that have the same absolute value. -7 and 7 both have an absolute value of 7. Any questions about that? Suppose we say the absolute value of x equals 12. What values of x would make this equation true? X could equal
-12 and 12.
Yeah, and I'm going to do the positive one first. So x could be 12 or x could equal, and I'm going to say the opposite of 12 or -12. Okay? So x could be this number, or it could be the opposite of that number. What if I said the absolute value of x is 72? Well, then x could equal what?
72 or -72.
72 or -72, said the small, quiet voice, who was correct. All right, are you seeing a pattern? Let's see if you are. Let's say the absolute value of x plus 4 equals 8. Well, then x plus 4 would either have to equal 8 or x plus 4 would have to equal
8 take away 4. Sorry.
the opposite of 8. Think about this, okay? Let's see here. This quantity if that quantity equals 8, what would its absolute value be?
8.
Okay. If this quantity equals -8, what would its absolute value be?
8.
So this quantity has to either equal 8 or this quantity has to equal -8. So what's inside the absolute value on the left has to equal what's on the right, or what's inside has to equal the opposite of what's on the right, because then if you take its absolute value, you still get the number on the right, at least in the scenarios we're looking at. Let's do another one. Oh, wait, let's finish this problem. So if we've got x plus 4 equals 8, or x plus 4 equals -8, subtracting 4, we get x equals 4. Subtracting 4, we get x equals -12. Well, let's check our work. Let's go back here. Let's see here. If I take the original, okay, something's wrong here. What have I, oh, there's a 4 there. I'm going, what? That's not right. I erased too much. All right, if x is 4, and I put 4 in there, what's 4 plus 4? What's 4 plus 4?
8.
Thank you. You were scaring me there. What's the absolute value of 8?
8.
8, okay. What if x is -12? What's -12 plus 4?
-8.
What's the absolute value of -8?
8.
8.
8. So both these answers work, okay? So in each case here, we're getting two equations. Let's say we've got the absolute value of 2x minus 5 equals 15, okay? So that means that 2x minus 5 either has to equal 15, because the absolute value of 15 would be 15, or 2x minus 5 has to equal the opposite of 15, or -15, because if 2x minus 5, if the stuff inside equaled -15, but you took the absolute value of -15, what would you get? You'd get 15. So what's inside has to either equal what's outside or the opposite of what's outside. When I say outside, as in on the other side of the equation. So 2x minus 5 equals 15. Let's add 5 to both sides. 2x equals 20. Divide by 2, x equals 10. 2x minus 5 equals -15. We'll add 5 to both sides. 2x equals -10. Divide by 2, x equals -5. Let's check our solutions. Let's take x equals 10. Well, we'd get 2 times 10 minus 5. Absolute value equals 15. What's 2 times 10?
20.
What's 20 minus 5?
15.
What's the absolute value of 15?
15.
Check. Let's take x as -5. What's 2 times -5?
-10.
What's -10 minus 5?
-15.
What's the absolute value of -15?
15.
Check. I'm having fun drawing circles or ovals or whatever. All right. Are you seeing that?
Yes.
Okay, how about this? So what should we do here?
3x equals 7, or
I'm going to start with what's out there and then the opposite. Follow what I'm saying? In other words, what's inside equals what's outside, or it equals the opposite of what's outside. That's why I wrote the negative first this time, because that's what was outside.
okay.
All right, so
So
here
then
we divide both
divide-
sides by 3. Yeah, x equals -7/3. Here we divide both sides by 3, x equals 7/3. All right, well, if x is -7/3, and we plug that in here, we get the absolute value of 3 times -7/3, which would be the absolute value of -7, which would be 7, right? So that one doesn't work. If x is 7/3, we get 3 times 7/3 absolute value, which would be the absolute value of 7, which is 7. That one doesn't work either. Now, here's a, I don't want to call it a conflict, but last quarter, I told students, if you've got an absolute value set equal to a negative number, an absolute value can't be negative, so there's no solution. So you can just look at it. If you see that, you could say no solution and stop. However, what WebAssign wants you to do, it wants you to ignore the fact that there's no solution. You're going to take it and you're going to come up with these proposed solutions. And then I can't remember what it says. It asks you whether the solutions work or not. Some kind, you'll see it in the language there. Okay, but so no shortcuts to satisfy what WebAssign wants. You would still solve it, get these answers, see that they don't work, and then you declare them as like extraneous solutions or something like that. Okay, I say you'll see that. But all right, you okay with that?
Thanks for the heads up.
You're welcome. How about this one? X plus 4 absolute value equals 0. Well, you've got what's inside equals what's outside, or what's inside equals the opposite of what's outside. But isn't 0 and -0 the same thing?
Can 0 be negative?
Well, sure, but it's still 0. You could have +0 or -0. It's still 0. Okay. See what I'm saying? Don't overthink
Right.
it. My point
Okay.
is, when you've got an absolute value equal to 0, there's really only going to be one unique equation, because the other one's going to give you the same thing. -0, 0, same thing. Okay. So this is just going to have one solution. So if you've got an absolute value equal to a positive number, there's the potential for two different solutions. If you've got it equal to a negative number, there's going to be no solution, but there's going to be two potential solutions. You find them and then say, they aren't going to work. If it's equal to 0, you're going to have just one solution. Okay? Now, what if you've got something like this? 2 times the quantity absolute value of x plus 4 minus 10 equals 40. Okay? So you got a whole bunch of stuff going on the left-hand side and just a number on the right. If there's just one absolute value term in the equation, the first process you want to do is to isolate that absolute value expression. So what I'm going to do first of all is I'm going to add 10 to both sides. I am not going to distribute. I am going to divide both sides by the 2. Now, after I have isolated the absolute value, I will get my two possible equations. X plus 4 equals 25, or X plus 4 equals the opposite of 25. But only after you've isolated the absolute value. If you don't do that first, you're going to have issues. Okay, and you don't want to have issues. All right, unless it's Issues of Life magazine or something. Okay, X plus 4 equals 25. Subtract 4, X equals 21. X plus 4 equals -25. Subtract 4, X equals -29. All right, here we go. Hang on to your hats. If X is 21, what's 21 plus 4?
25.
25. What's the absolute value of 25?
25.
25.
What's 25 times 2?
50.
What's 50 minus 10?
40.
Check. All right. Let's see. It was 2 times the absolute value of x plus 4 minus 10 equals 40. If x is negative 29, what's negative 29 plus 4?
Negative 25.
What's the absolute value of negative 25?
25.
What's 25 times 2?
50.
What's 50 minus 10?
40.
40 equals 40. Check. I'm just doing that instead of writing an entire new thing on the next page. But checking your work, they both work. Always check your work though. Okay, because think back to this problem. If we hadn't checked our work, it would have been like, oh yeah, we got 2 answers, but neither one of them actually work. Okay. Let's see here. Oh, let's say you've got 2 absolute values. Absolute value of x plus 7 equals absolute value of 2x minus 3. Okay. Let me backtrack a little. If you've got 1 absolute value in the equation, isolate it. If you have 2 absolute values, you want them on separate sides of the equal sign, just like they are here. Now, I want to look at 4 different cases. We're going to come back to that problem in a minute. Is that true?
Looks true.
Is that true?
Same.
Is that true?
Yep.
Is that true?
Yes.
No, it's hard to read
If
that.
that's
Those
a
are all-
7.
They're supposed to be 7. Sorry. Okay. Wasn't trying to trick you with my sloppy writing, but I did. So what we've got here is either this. So that could be true. That could be true. That could be true. That could be true. So we could take what's inside equals what's inside. That's the first example. The opposite of what's inside equals the opposite of what's inside. That's the second example. What's inside of the first equals the opposite of what's inside the second. That's the third example. And finally, the opposite of what's inside the first equal to what's inside the second. So there's those 4 cases. But look closely. These 2 cases are actually the same equation. If we take this first equation and multiply both sides by -1, don't we get this second equation?
Yes.
Isn't this just negative times what's inside, negative times what's inside? So these 2 are the same, so I don't need this example. Okay, take a look at those 2. If I take this equation and I take the opposite of each side, I'd get this and this. Oh, wouldn't I get the bottom equation? Isn't taking the opposite of that going to give me this? And taking the opposite
Yes.
of negative? Okay, so I don't need that equation. So what it amounts to is I've really only got 2 cases. I'm going to take what's inside equals what's inside, and then I'm going to take what's inside of one equals the opposite of what's inside the other. Because if you do the other 2 cases, you just get redundancies. You're getting the same solutions. Okay. All right. I'm going to do a quick review here. Let's see here. So if you've got an absolute value set equal to a positive number, what's inside is equal to the positive number, or what's inside could be equal to the opposite of that positive number. Solve the equations. If you've got, let's see, well, that was the same idea. If you've got what's an equation, absolute value equal to a negative number, you're not going to get a solution, but you still need to solve it. So you're going to take what's inside equals what's outside, or what's inside equal to the opposite of what's outside, solve it, check it. They're extraneous solutions. They don't work. If you get an absolute value equal to 0, you only get one unique equation, solve it, check it, see if it works. If you got a bunch of stuff outside of the absolute value, isolate the absolute value first. Get rid of any extra constants, any coefficients, deal with both sides. So you're down to where you've got just the plain old absolute value equal to whatever, go from there. If you've got two absolute values, you want them separated, one on each side of the equal sign. All right, time's up, gotta go. New Zoom meeting starting quickly. I'll be back at 1:15. And as I say, I will try and contact the people whose questions I didn't get to today to see if you still have questions. Have a good rest of the day.
Thank you.
Thank you, Mr. Mayo. You